This is the famous pale blue dot image taken by Voyager 1, showing our Earth as a tiny pixel 6 billion kilometers away. This image was taken before many of you were even born, but the elements and materials that made us are all contained in that tiny blue dot we call home. But this date is significant. Just 34 minutes after this picture was taken, the cameras were switched off forever, leaving Voyager 1 completely blind. Since then, the spacecraft has become the furthest man-made object in space, now at a point 24 billion kilometers from Earth. But why were the cameras turned off? And what would it take to turn them back on? The Voyager space probes have broken so many records during their time in space. Not only are they the furthest objects in space, but they've also been operating for the longest amount of time, over 45 years. Voyager 1 was filled with technology that was way ahead of its time, and a perfect example of that is the camera system. Voyager 1 has two Vidicon cameras on board, which are essentially very early television cameras, using analog to digital technology. They had an effective resolution of 800 by 800 pixels and captured 8-bit images in grayscale. One had a wide-angle lens for capturing the planets in full detail as the probe passed close by. The other had a narrow-angle lens and could capture the smaller details of each planet it observed and, of course, look back at our solar system as it grew smaller and smaller on the horizon. However, before the light reached these cameras, it went through an optics system that allowed it to form colored images. This was a filter wheel that contained violet, blue, green, and orange filters. Voyager would take multiple images of its subject using each of its filters. As the light passed through the filter, it would only allow light from that color to pass through, and other colors would be absorbed. The images were still taken in grayscale, but each image would have areas with different amounts of brightness, where the light was more sensitive to a certain color. After these images were sent to Earth, they were saturated with their respective filter color and combined to form a full-color image. But with Voyager 1, the real magic happens inside the Vidicon tube. After the light passes through the lens and filter wheel, it enters into the Vidicon tube. The first thing the photons hit is a see-through faceplate made from a layer of tin oxide, which has a photoconductive target plate just behind it. When the photons hit the target plate, free electrons are created. The higher the intensity of light on any given point, the more free electrons are created. These free electrons are then attracted to the faceplate, leaving behind gaps on the target plate. After this, a cathode at the back of the tube fires electrons towards the target plate to scan the image. These electrons reach the target plate and fill in the gaps, creating an electric current. This signal contains the image data and can now be transmitted back to Earth. But why hasn't Voyager's camera been turned on in over 30 years? To answer this, we need to look at where Voyager 1 was when it took its last picture. The famous pale blue dot image was taken from a point in space 6 billion kilometers from Earth. At this point, the spacecraft was so far away that everything appeared as a tiny dot. The spacecraft was also headed on a path that would eventually make it the first spacecraft to leave the solar system and reach interstellar space. So in order to know when this happened, the team wanted to prioritize the instruments that would detect interstellar plasma, a sign that Voyager 1 had left our solar system. But Voyager 1 was already 13 years old at this point, and it still had decades to go before reaching interstellar space. So, in order to still be talking with the spacecraft at that point, the engineers needed to extend its lifetime drastically. Like many spacecraft, Voyager 1 is powered by an RTG, which takes the heat from a radioactive material and turns it into electricity. Every year, the power output decays by about 4 watts, and now, Voyager 1 is only producing 57% of its initial power output. The camera system alone uses just over 40 watts of power. And so, to buy the spacecraft more time, the team began shutting down various instruments on board Voyager to reduce its power consumption. To save memory, the team also removed the software on board Voyager, which was responsible for operating the camera. The cameras and software here on Earth that were used to analyze the images don't even exist anymore. And due to the cameras and their heaters being exposed to the harsh conditions of outer space for several decades, it's likely that they wouldn't be able to function anymore. But assuming the cameras were still in good condition, what would they see if they were turned back on? Many think that Voyager 1 is so far from the Sun that it will be in complete darkness, but this is not true. Despite now being 23 billion kilometers away, the light from the sun is still 16 times brighter than the moonlight here on Earth. However, there just isn't anything interesting or big enough around Voyager to capture on camera. If Voyager took an image today, it would be dark, but you would still see the sun and some planets as tiny, faint pixels. Perhaps the most incredible thing is that despite traveling 23 billion kilometers, the star constellations in our sky would look exactly the same. If Voyager wanted a different perspective of our galaxy, it would need to travel thousands of light years just to see a slight shift in the stars. Voyager 1 will eventually achieve this, millions of years after we are gone, and long after we have lost contact with the space probe.